Okay, this is part 3 of our screencast series on simple Haar Wavelets, and we're going to be talking about, in this part, about the shifts and dilations of the basic Haar transform. So let's suppose that, just to review, backtrack, we have a sample of two values, S0 and S1. Then the value of S0 plus S1 over 2 is the average of the approximating function f. Right, that's the sample, and then that approximates some signal. The sample approximates some signal, and the value of S0 minus S1 over 2 gives us the estimate of the change in the approximating function. So the approximating function is defined as, for this sample, given this sample, is defined as S0 times phi from 0 included to half excluded plus S1 times phi from half included to 1 excluded. And this is in turn can be defined in terms of a larger interval as S0 plus S1 over 2, the average, times phi from 0 included to 1 excluded, plus S0 minus the average, right, as S0 and plus change is 0 minus S1 over 2 times psi, the wavelet, from 0 included to 1 excluded. So let's suppose that we have sample 8 and 2. Right? That's our approximating function. So this is equal to, the approximating function can be defined as 8 times phi from 0 included to half excluded plus 2 times phi from half included to 1 excluded equals 8 plus 2 over 2, the average, times phi on the larger interval from 0 included to 1 excluded plus 8 minus 2 over 2, the change of psi, the basic wavelet, from 0 included to 1 excluded. So this is in turn equals to 5 times phi from 0 included to 1 excluded plus 3, 8 minus 2 over 2, times psi from 0 included to 1 excluded. So here is the graphic representation of this example. So we have a sample of size 2, so consisting of 2 subintervals. All of the samples are even size. The first subinterval is from 0 to half and has the value of 8, and the second subinterval from half to 1 has the value of 2. And this is equal to, this can be represented as the average, which is 5, over the entire interval, right, from 0 to 1, there's a 5, right, plus the wavelet. This is from 0 to 1, 5 times phi from 0 included to 1 excluded, plus the wavelet, which is whose coefficient is 3, the basic wavelet whose coefficient is 3. So that goes from 0 to from 3 to minus 3, and has the value of 3 on the interval from 0 to half, and minus 3 on the interval from half to 1. Right, half included, 1 excluded. Right, so it's minus 3 and then 3. So 5 plus 3 gives us 8. on the first subinterval from 0 to half, and then 5 minus 3 gives us 2 on the second subinterval from half to 1. Okay, well, let's suppose that we want to do the wavelet from some other location other than 0 and 1, say on the interval from u and w. Right, so we can define the middle of that interval, right, and then compute this is psi, the basic wavelet, and then define psi from u included to w excluded as, okay, so some value r as equal to 1 if r is greater than or equal to u but strictly less than half u plus w over 2, and minus 1 if the value of r is greater than or equal to half u plus w over 2, and strictly less than the end of the interval w, because we have u included and w excluded. So greater than or equal to r, u plus r is greater than or equal to u plus w over 2, and less than w, then the value of psi from u included to w excluded of r is minus 1. So let's name this m. So then we can define phi from u included to w excluded as phi from u included to m excluded plus psi from u phi rather from u from m, right, the sums, right, so phi from u included to m excluded plus phi from m included to w excluded, and then psi, the wavelet from u included to w excluded, is going to be the difference of phi from u included to m excluded and phi from m included to w excluded. So let's do the same trick as we did in the previous screencast. We're going to compute the sum and difference of these two equations. And in a sense, you can think of it as dilation, because we're basically representing a smaller, we will represent a smaller subinterval in terms of the larger subinterval. So summing up, we get phi from u to w plus psi from u to w, that's the left hand side of both equations, equals 2 times phi from u to m to the middle, so which gives us the representation of phi from u to m in terms of a larger interval from u to w. Right, so it gives us phi. So phi from u to m is equal to phi from u to w plus phi from psi from u to w divided by 2. Okay, and then the difference also gives us a way to represent a smaller interval in terms of the larger interval. So phi from u to w, u included, w excluded, minus psi from u to w is equal to 2 times phi from m to w. M included, w excluded. Okay, and then phi from m to w the smaller the right subinterval can be expressed in terms of the larger interval from u included to w excluded. Phi from u to w minus psi from u to w divided by 2. So, as we will discover later, Haar transforms are applied to even size samples. So let's suppose that, well, if our sample is odd, we can simply pad it, either on both ends or on the left end or the right end, depending on our application needs. But we can think of the basic Haar transform applying to a sample as applying the transform to the first pair of values, then dilating the first pair of values, then shifting and dilating the second pair of values, and so on until we reach the last pair of values. So let's work out an example. Let's suppose that our sample consists of 4 values: 7, 3, 4, and 10. Okay, so this is our S0, 7, S1 is equal to 3, S2 is equal to 4, and S3 is equal to 10. So the first pair, 7 and 3, and the second pair is 4 and 10. So we're going to dilate the first pair and then dilate the second pair. Right, shift and dilate the second pair. So so there are 4 subintervals from 0 to 1 over 4, from 1 over 4 to 1 over 2, from 1 over 2 to 3 over 4, and from 3 over 4 to 4. So on the first subinterval we have the value of 7, now on the second subinterval the value of 3, on the third subinterval the value of 4, and on the fourth subinterval the value of 10. Right. So that's our frequency. Right. We get 4 readings. So the approximating function f tilde can be represented as 7 times phi from 0 included to 1 over 4 excluded, plus 3 times phi from 1 over 4 included to 1/2 excluded, plus half excluded, plus 4 times phi from 1/2 included to 3 over 4 excluded. And plus 10 times phi from 3 over 4 included to 1 excluded. Okay, so let's dilate the first pair of values, 7 and 3. We'll get 7 times phi from 0 included to 1 over 4 excluded, plus 3 times phi from 1 over 4 included to 1/2 excluded, plus 3 times phi from 1 over 4 included to 1/2 excluded. So you remember the intervals are always closed on the left and open on the right, so half open intervals is equal to 7 plus 3, so we're dilating. So average, and then the larger interval, phi from 0 to 1/2. Right, so 2 subintervals are dilated into one larger subinterval, half interval in this case. And plus, so this is 5 times phi from 0 to 1/2, and then the wavelet is 7 minus 3 over 2 times psi from 0 to 1 over 2. Okay, so that's gives us 2, right, the coefficient of the wavelet. And then let's dilate, shift and dilate the second pair of values, S2 and S3. So that gives us 4 times phi from 1 over 2 included to 3 over 4 excluded, plus 10 times phi from 3 over 4 included to 1 excluded. Okay, and then dilating them into a larger subinterval or half interval, it's going to be 4 plus 10 over 2 times phi from 1/2 to 1. Right, we've combined them into a larger interval, plus 4 minus 10 over 2 times phi from 1/2 to 1, psi rather. It's the wavelet, psi from 1 over 2 to 1. Okay, let's get some space on the whiteboard. Okay, so phi, this is f tilde, original approximating function, 7 times phi from 0 to 1 over 2, 0 included, 1 over 2 excluded, plus 3 times phi from 1 over 2 included to 1/2 excluded, plus 4 times phi from 1/2 included to 3 over 4 excluded, plus 10 times phi from 3 over 4 included to 1 excluded, equals 5, which is 7 plus 3 over 2, times phi from 0 to half, 0 included, half excluded, plus 2, 7 minus 3 over 2, times psi from 0 included to half excluded, plus 7, 4 plus 10 over 2, times phi from 1 over 2 included to 1 excluded, plus minus 3, right? 4 minus 10 over 2, plus minus 3 times psi 3 times psi from half included to 1 excluded. So what does that mean? Okay, well, it means that on the first half interval from 0 to half, the approximating function f has an average of 5, right? And so average of 5 on the interval from 1 or from 0 to included to 1 over 2 excluded. Right, this is 5, and then it also undergoes a jump of size 2 times the size of the basic wavelet, which is minus 2. So 2 times minus 2 gives us 4, right? And indeed, you get 7 plus minus 4 gives us 3. So there is a jump. So the average is 5 on the first half interval, and there is a jump of a size minus 4, which brings the value of 7 to the value of 3, the value of S0, which is 7, to the value of S1, which is 3. Okay, just remember that the size of the basic wavelet is always minus 2, right? From 1 to minus 1. You can review the previous screencasts. We've discussed that issue. Okay, and on the second half, the average is 7, right? 4 plus 10 over 2, and then the sample undergoes a jump of size minus 3 times minus 2, which is 6, which is 4 plus 6 gives us 10. So the sample jumps from 4 to 10. Okay, thanks for watching. This is to be continued.